Alrighty, so I am going to ask you to just answer these simple starter questions. Like always, I always like to start off with something simple, and then show you, what the idea behind simplifying, just regular fractions with numbers is. And then we're going to extend this logic to rational expressions. Okay, so I'm pretty sure all of you know how to do these questions. Um, but what I'm going to do is I'm going to point out why it simplifies to whatever your answer is. Okay, so again, so just I guess I want you to find the answers, obviously, but also think about why is this the answer. Okay, so try doing that, but obviously I'm going to continue. Okay, so with the first question, right? Just by looking at it, some of you can say that, well, it's just 3/4, right? So yes, it is. But how do you get the 3/4, right? So the idea is you're going to have to break your numerator as a product of prime numbers. Okay, so you're essentially factoring it. Okay, so I'm going to rewrite 15 as 3 times 5. Okay, why 3 times 5? Because I cannot, break 3 anymore. It's a prime number. Okay, same thing with 20. So 20 is 4 times 5, but 4 is not a prime number. So it's actually 2 times 2 times 5, right? And by doing this, guys, what you can do is, because it's multiplication, only works with multiplication, okay? You can cross out the numbers that are repeating themselves in the numerator and denominator, okay? So you see a 5 on top and a 5 at the bottom, okay? And, the reason why we can cross this out is because 5 divided by 5 is just 1, right? So it's kind of like redundant in the sense that this can be simplified. And when you do that, right, that's how you get, right, because the 3 survives, right? So you have 3 on top, and 2 times 2 is just 4. Okay, so that is the logic that we're using here. Okay, so same thing with the other question. So right, 30 is just if you want 10 times 3, 15 times 2, however you want to do it. But again, try to break it down to prime numbers. Okay, so 15 times 2 is good, and it will actually work. But just to avoid any confusion, because sometimes, sometimes you can simplify the fraction, but then you can simplify a bit further, right? So to um, go to the simplest form, I guess, you need to break this down to prime numbers. Okay, so 15 is 3 times 5, right? And then 15 times 2 is 30. Okay. And again, I'm not going to ask you to draw the tree, right? 30, kind of like what I'm teaching. Well, I taught my 10 C's, right? 2 times 15 and then 3 times 5. This is kind of like how you get those numbers, but, I'm not, this is just a side note. Okay. So 45 is, I think, 15 times 3. So 3 times 5 is 15, but instead of 2, you're going to have 3, okay? And you see, as you can see, right, because it's multiplication, okay, again, only works if you have multiplication in your denominator and multiplication in your numerator, okay? It does not work with addition. You can just create an example for yourself and see that it will not work, okay? So the numbers there are repeating themselves, right? Because 3 divided by 3 is just 1, 5 divided by 5 is also 1. So this is how you get the 2/3 from 2/3. Okay? We all know the answer is 2/3. Okay, but why is it 2/3? This is the reason. Okay, and here, right, this what you did in 10C was, you know that you just have to subtract your exponents, right? So there are two bases, m and n. So your bases will not change. Sorry, that should be an n. And then you just subtract your exponents, right? So 2, if the exponent is not visible, it's 1. So 2 minus 1 is just 1, and then 5 minus 3 is 2. So this is your final answer, right? But this logic, right, this logic over here can actually be applied to this question as well, okay? So using the logic that I introduced up for, I guess, question, let's say, these two questions, right? Let's break this apart. So m squared is just m times m, and then n to the 5 is, maybe I shouldn't have chosen 5, but whatever. So it's n times n times n times n times n, okay? So I'm just breaking it apart. And then in your denominator, you just have m, and then you have times n, and n is repeating itself 3 times, okay? And as you can see, right, because it's all multiplication on top and at the bottom, M divided by M is 1, and then your n's will also cancel out, okay? So they will just give you 1, 1. So this becomes, right? So this simplifies to m, right, times, so this m survives, and then n times n, which is n squared, okay? And in your denominator, everything cancels out. So, essentially, you only have 1 left. So you could put n squared over 1, but like that one is redundant, okay? So let's not do that. So let's just leave it like that, okay? So this is what we have to do with our rational expressions. Remember, in your numerator and denominator, as you will see in the next question, right? You'll either have a linear function or a quadratic function, and then you'll just have to factor those. Okay, you'll have to factor those. Why? Because when you factor, um, it changes this. Right now there's a subtraction, there's an addition, subtraction, right? It changes that into a product. Okay, and you can, like I said, you can only simplify, you can only cross things out when you have a product. Okay, so going back to my first example, if you want, okay, so um 15, right? So we have 15 over 20. 15 over 20, if I write this as, a sum, it's also 10 plus 5 over 10 plus 10, right? I cannot cancel the 10s out, because if I do, that leaves me with 5 over 10 on top, right? 5, oops. So if I do that, that leaves me with 5 over 10. But 15 over 20 is 3 over 4. It's not 5 over 10, which is equals to a half, right? So as you can see, this crossing out business, right, does not work when you have an addition. Okay, it only works when everything is a product. Okay, so don't do that. Okay, if that were the case, then we wouldn't have to factor anything, right? We could have just crossed things out, but it doesn't work like that. Okay, so let me do the question for you. So let's start off with question A, I guess, right? So let's focus on the numerator, right? Even though it's a linear function, it can still be factored. Right? You can pull out a GCF. What's the biggest number that divides? And you will have to factor. Okay, if you don't factor, then it will not work out for you. Okay, so this kind of like will force you to factor. If you forgot, like some of you might just factor the denominator, right? Because it's a quadratic. We know that that will obviously get factored. But if you forget about the numerator, then this will not work. Okay, and I'll highlight that shortly. Okay, so you factor a GCF, right? So 3 is the GCF. So, right, so because I factored 3, the question is, what do I need to multiply 3 by to get 3x? So this will just be x, and then what do I need to multiply 3 by to get minus 6? Well, it will be minus 2, okay? It's kind of like the opposite of distributing, right? So 3x minus 6, okay? So I haven't changed anything. I've just rewritten 3x minus 6 in a different way. And then I have my denominator, okay? So, and this might take me 2 pages, so I'm kind of ready for this, okay? So I actually have that extra page down there, so I think we should have enough space. Now, the denominator is obviously more difficult, right? Because so if you've forgotten, right, a squared plus bx plus c, right? So when you factor that, the product is always a times c, and the sum is just b. Okay, so two numbers that multiply to 2 times negative 10, so minus 20, and then they have to add up to my b coefficient. If it's not visible, it has to be 1. Okay, so again, if you're not very good at finding the combination, start with 1 and 20. It's not going to work. 2 and 10, it's not going to work. 3 doesn't divide 20, so you skip that. 4 will work, okay, because 4 times 5 gives me 20. But this is negative, so one of them has to be negative, right? But 1 is positive, so that means the smaller one of the two numbers has to be negative. So the 4 actually has to be negative, okay? So minus 4 plus 5, okay? But you see, this is not that simple, because you cannot use the shortcut, kind of like what I did with the previous video, okay? Here you'll have to, again, you could, do it separately and then put the answer in your denominator, right? I'm just gonna do it here, I guess. So the combination, right, tells you to rewrite the middle term in an intelligent way. Okay, so we're going to write x in an intelligent way. So 2x squared doesn't change, but then I'm going to put the first number, which is minus 4, add an x to it, right, and then put the second number, which is 5, and add an x to it, and then minus 10, okay? So I didn't change anything. I have exactly what you see up here, okay? Only thing is, I have written this plus x in an intelligent way, okay? So 2x squared is still down here, minus 10 is still down here, but remember, minus 4x plus 5 is just x, right? So I haven't changed anything. I've just written it in an intelligent way, okay? So now let's proceed. So what will happen? Well, once you do this, right, once you have four terms, the idea becomes to, there's a reason why we want four terms, because now we can do grouping, right? So target on the first two terms, because obviously you cannot factor the whole thing, right? You cannot factor the whole thing. Otherwise, I would have done that at the beginning, right? So because we cannot factor the whole thing, I'm going to target my first two terms. And right, so in the next line, so let's just say equals. Numerator doesn't change, right? So let's just keep that here for now. Denominator will, right? So what can I factor here? Well, 2 divides 2, it also divides 4, so I'm going to factor 2, and I'm going to factor the lowest exponent, okay, the lowest exponent of my x value, which is just 1. So the x that has the lowest exponent is x exponent 1, right? Or exponent 1. You don't have to put that there, okay? And then you open your brackets, and then you ask yourself, what do I need to multiply 2x by to get 2x squared, right? So that's just x, and then minus 2, okay? So once you have x minus 2, you should know that this x minus 2 has to repeat for it to work, okay? So let me put the x minus 2 here. Now the question becomes, what do I need to multiply this x by to get 5x? And the answer is, well, just 5, right? And then you check, does 5 times negative 2, right? Does 5 times negative 2 give me negative 10? Yes, it does. So that means you've done this correctly, right? And then finally, right, now, right, the idea of doing all this is because now, as you can see, you can actually factor out the x minus 2 because it's repeating itself, right? So when you do that, this becomes 3x minus 2 over my denominator. I'm going to factor x minus 2. And once I factor x minus 2, that leaves me with 2x. And it leaves me with plus 5, okay? Now, once you factor everything completely, because this is asking you to simplify, but it's also asking you to state the non-permissible values, right? So once you factor everything completely, before you simplify, state the restrictions, okay? So based on what I have in the denominator, right, by looking at this, okay, before simplifying, because if you simplify, you're gonna exclude one of your restrictions, okay? So that means my restrictions are x minus 2, right? For me to have restrictions, my denominator has to equal to 0. So my denominator will only equal to 0 either if this is equal to 0 or if this is equal to 0, right? And then just solve for x. Okay, I'm not going to spend too much time doing that. So x is equals to 2, x is equals to 0, and then x minus 5, right? So minus 5 over 2 if you want, okay? Or minus 2.5 for those of you who like decimals. Okay, so my restrictions are, right? My restrictions are, this is just a comma, okay? I'm just putting a comma over here. X cannot equal to 2, and x cannot equal to minus 2.5. Okay, so these are my restrictions, guys. Okay, these are my restrictions. Now, final step, you have to simplify. As you can see, the x minus 2 and the x minus 2 will cancel because it's the same thing in your numerator and denominator, right? Now, had you forgotten, right? Had you forgotten to simplify, had you forgotten to factor your numerator, you wouldn't have been able to cancel out the x minus 2 and x minus 2, right? So as you can see, it's designed in such a way that if you factor everything, right, numerator and denominator, only then you will be able to cancel things out, okay? So this simplifies to, right, so if you want, this just simplifies to 3 x minus, oh, well, minus 2 has disappeared, right? So this just simplifies to 3 over 2x plus 5, okay? Okay, as long as your restrictions are x cannot equal to 2 and x cannot equal to, um, not n, maybe, let me just, I mean, you could put n if you want, but, x cannot equal to 2. Let's just stick with comma. X cannot equal to negative 2.5. Now, you see in this function, right, let me just be very careful. I see too many commas, so let's just remove that one. In this function, if you put x is equals to 2, there is no issue, right? Because 2 times 2 will give you 4. 4 plus 5 will give you 9. So there is no issue, but you still have to keep the same restrictions, okay? You still have to keep the same restrictions because they apply to the original question. What we did over here is it's the same thing. We've just made we've just crossed out the x minus 2 on top and at the bottom. But you still have to keep this restriction, okay? So in other words, I guess what I'm trying to tell you is that if you graph this function over here, and if you graph this one, they will be one and the same. The only difference is, you know, the x minus 2 over here will have a kind of like an open circle in your graph, and this one will not. And I guess Desmos can kind of show that to you. Let's just not go into the details, okay? What I really want you to understand is that the restrictions will still be the same, okay? Will still be the same even though x is equals to 2 is not a problem for this denominator. I want you to keep the restrictions the same, okay? So let's do one more question, right? So part B, for B, we have 1 minus t over t squared minus 1, right? T squared minus 1. As you can see, right, once you start seeing quadratics, right, especially when you see a minus sign, this should automatically tell you that this is a difference of squares, okay? So I can't really factor anything on top, but at the bottom, right, this just becomes t plus 1, right? You take the square root of the first term, take the square root of the second term, and then put a plus sign in between, and then rewrite the same thing with a minus sign, okay? So again, if you want, you could put brackets over here, okay? And again, as you can see, I can't really cancel anything yet. I guess yet is a nice word to use. But t minus 1 and 1 minus t, are not the same because here the t is negative. Here it's positive, right? But here the 1 is negative and this is positive. So they're off by a minus sign. So what you could do is, okay, what you could do is just factor out a minus 1 in your numerator. Okay, so even though you don't have to, but your denominator kind of is forcing you to do that. Okay, so if I factor a minus 1 in my numerator, then my t, right, which is minus t over here, minus t, becomes positive. This will just become t, and then the positive one will become minus, okay? And then you have now t plus 1 in your denominator, and then t minus 1, okay? So this will just cancel out now, okay? So, again, like I said, these questions are designed to simplify, right? So when you see something like 1 minus t, oops, let me keep the same color, right? 1 minus c, t minus 1, they look almost the same, okay? So when it's almost the same, you're only off by a minus sign, factor the minus 1. You could have factored the minus 1 in your denominator too, and it would have worked, okay? I just chose the numerator because I think it's a lot simple to visualize, especially for you guys. Okay, so let's just keep it simple. Okay, so that's how you would simplify. So you know what? Let me do. So this is my final answer. Okay, before I start crossing things off. Once you get to this stage, this will tell you what the restrictions are. Okay, before you cross things off. So my restriction is t plus 1, right? For my denominator to be 0, either t plus 1 has to equal to 0, so that means t has to equals to minus 1, right? Or t minus 1 has to equal to 0. That means t has to equals to 1, right? So my restrictions are t cannot equals to minus 1, and t cannot equals to 1, okay? And then now you cross it off, okay? So this is where I would cross it off. So this is my final answer, right? So my final answer is minus 1 over t plus 1 with the restrictions, right? With the restrictions that, um, with these restrictions, okay? I'm not going to rewrite them again, but these are your restrictions, okay? So again, guys, I'm going to emphasize this like so many times I've done this, but I'm going to do it one more time. Restrictions, before you start crossing things off, figure out what your restrictions are, okay? Once you cross things off, you're going to lose some of your restrictions, okay? So before crossing them out, figure out what the restrictions are, okay? And then cross them out, okay? So now what I want you to do is I want you to practice by simplifying um, these, I guess, fractions, right? These rational expressions. And while you're simplifying, also state the non-permissible value, okay, or the restriction, okay? So pause the video, try doing these questions. I'm just gonna proceed anyway. So, you know, so yeah, so let's do the first question again, right? So um, we're gonna have to, we have two quadratics, right? So we're gonna have to go with the product sum method. So let's work with the numerator. So denominator is really easy, okay? So we have ax squared plus bx plus c, right? So let's do, you know what? Let's do the numerator in red so that, you don't get confused. So let's just do this in red. And then the other one, I'm going to do that in blue. Okay, so is it the same question? Two numbers that multiply to? It looks like the same to me. Minus 20 and add up to 1. It is the same. Okay, so I'm not going to do this twice. You see this 2y squared plus y minus 10 is the same as 2x squared plus x minus 10. Okay, so minus 20 and then 1, right? So yeah, okay, so I know what this simplifies to. Maybe you guys did the work, but I was a little bit clever over here and I'm getting a little bit lazy, but that's fine. So I know what my numerator will simplify to. Okay, I'm just gonna look at the question over there. So let's do the blue stuff. Okay, so let's do this guy. I'm looking for two numbers that multiply to minus 10, right? Because this is a 1. If you don't see it, 1 times minus 10 is minus 10, and it needs to add up to my b coefficient, which is 3. Okay, so again, if you don't know what the answer is, try 1 and 10. That's not gonna work. 2 and 5, I think will. Okay, so 2 times 5 is 10. One of them has to be negative, and because this is positive, then the smaller one has to be negative. Okay, so minus 2, 5. And this one is easy because my coefficient, guys, is 1. Okay, my coefficient is 1 over here. So that means that I can use my shortcut. Okay, so hopefully I did the other question correctly. So where is the answer? It was x minus 2, 2x plus 5. Okay, so the top part, right, should factor to x minus 2, 2x plus 5. Okay, and the bottom part simplifies to using my shortcut. Okay, because the coefficient is 1, I'm just going to put x and my first number, which is minus 2. And then I'm going to put x, right, open another bracket, and then my second number, which is plus 5. Okay, and okay, and now, right now, before you cross things out, I know once you get to this stage, it's really tempting, right? Because you see the x minus 2, x minus 2. But before you get to this stage, I guess once you get to this stage, right? So this is equals to, right? This will tell you what the restrictions are, right? So this, right, tells me that x cannot equal to, or my non-permissible values 2, and x cannot equals to 5, okay? Sorry, minus 5. Right, because if you solve for your zeros, this minus 2 will become plus 2, and this plus 5 will become minus 5, okay? So now that I have my restrictions, I can just cross this out, and then my final answer will be 2x plus 5 over x plus 5. Now, I know it's really tempting, right, to cross out the x plus 5 and x plus 5, but please don't do that. The only way this would work is if this was if if this was something like that. Okay, so in other words, if this was instead of, so if you multiply this, so this becomes 2x, this becomes 10. So if this was 2x plus 10, then you could have factored the 2 and then crossed this out. But as it currently stands, as tempting as it may look, you cannot do that. Okay, so you cannot do that. So I'm just gonna put the brackets over here to remind you why you cannot. Okay, so you cannot do that. Okay, so just be careful. And again, you cannot also cross out the fives because it's addition. Okay, this crossing out business only works when you have a product. Okay, so this is my final answer. Okay, and now this one shouldn't be too long, right? So careful with your numerator, right? You can factor the numerator. So question B, biggest number that divides 2 and 6 is 2. So this becomes 3 minus m, right? Minus m. So because 2 times 3 is 6, yeah. And then, right, let's focus on the numerator now. Maybe let me use a different color. Oops. Okay, so whatever, let's go with red. Red. So, right, it's a quadratic function separated by a minus sign. Both of them are square numbers, right? This should like tell you that it has to be difference of squares. Okay, so how does difference of squares work? Well, you take the square root of the first term, it's just m, right? Plus square root of the second term, so the number that comes after the minus sign. So that's 3. And then rewrite the same thing with a minus sign, okay? But again, right, we have the same issue over here. M minus 3 and 3 minus m look very similar. So that means that we're off by a minus sign, right? So if you factor minus 1 from your numerator, in your numerator, then your top part will, because the minus 1 has to multiply with the 2, right? So the top part will just become minus 2 times the m, which is negative, will become positive. The 3, which is positive, will become negative, okay? And then you're going to have m plus 3 and then m minus 3, okay? I'm running out of space, but I do have that second page, so I'm just going to squeeze this in here for now. So m plus 3 and then m minus 3. Now, before you cross stuff out, right, state your restrictions. So restrictions are m cannot equals to minus 3, right? And m cannot equal to 3. Okay, so this plus 3, right, if you solve for your zeros, you know what? I'm just going to do this for you, okay? So let's just, right? So I don't want my denominator to be 0, right? So that's how you find the non-permissible value. So that means m plus 3. So my denominator will equal to 0 if m plus 3 will equal to 0, or if m minus 3 will equal to 0, and then just solve for m. Okay, so m will equals to minus 3, m will equals to 3. So there you go. These are my restrictions. Okay, so my restrictions are m cannot equals to minus 3, and m cannot equals to 3. Okay, and now you can, let me just put a box around it, right? So that you know these are your restrictions. And then finally, once you state your restrictions, then cross it out, okay? So this will just equal to, right? The final answer is this will just, this stuff over here will just equals to minus 2 over m plus 3, okay? And you can drop the brackets if you want. If you want to keep it, it doesn't really matter, but this is your final answer. But as you can see, right, if you look at this final answer, you're going to miss one of the two restrictions, right? So you're only going to have this one, but you're going to be missing out on that one, which is why I'm always asking you before you start crossing things out, right, at this stage, before you start crossing things out, make sure you state your restrictions. Okay, you cannot state your restrictions um, just by looking at this, right? Factor it so that it becomes more obvious. Okay, so factor it once it's completely factored, right? Once you reach this state, your restrictions will be very obvious. Okay, and you don't have to show this work, but if you know if you don't want to make silly mistakes, I think it's a wise thing to do. But like for someone like me, I would not show my work. But then again, right? So maybe in high school I did. I just don't remember. Okay, so this is your final answer, and these are your restrictions. Okay, so this will require some practicing. Okay, which is why I'm giving you a little bit of homework over here. So this is it for the whole week. I think I'm gonna be uploading both my videos, this one and the one that I just made on Tuesday. So, you guys spread it out, right? You can watch both the videos on Tuesday and have nothing for Wednesday. Or I think a wiser thing to do would be to watch one of the videos on Tuesday and save the other one for Wednesday. And on Thursday there will be optional office hours where if you have any questions, I can answer your questions. But there will not be a quiz this week, okay? Because we haven't covered much. So no quiz this week, but office hours, I will be holding them on Thursday to answer any questions that you may have. And also, some of you might have seen your grades change a little bit. So that's because everything that you're doing in remote learning is now actually counting as your final exam grade. So that is, one of the big reasons. But on Thursday, I think the principal will give us more information, and then, I will, I guess, give you more information. Um, um, so maybe not, right? Because I will give you more information next week because my meeting on Thursday will be at lunch and you guys are blocked too, so I wouldn't know what to tell you. The only thing that I can tell you now is that everything that you're doing for remote learning, which is fairly straightforward, right? It's just 1, 2 questions per week, is counting as your final exam grade. Okay, so it's a it's a nice way for you to boost your grades. Okay, I've seen students make a 15% increase. Some of my students have made a 15% increase. Only like 1 or 2 students have a lower grade now, and that's because I think they're just slacking off. Okay, so this is way easier than what we used to do because we've lowered our expectations. So please take advantage of this and try not to slack off. Okay, and that is it from me today, guys. So thank you so much. You have a nice day.